Am I audible? Good morning, students. Let me share my screen. Is my screen is visible? My screen is visible? No, ma'am. Okay. Yes, ma'am. Okay. Okay. Perfect. So today we'll start the new model, which is also called. Uh, it's it's shear force and bending moment diagram. Okay. The force, um, the force carried by these slender members. So slender members, under the slender members, you will have a beam, struts. Okay. So we'll start with beam. So, see, how many participants? 23. Okay, let's start the class. So, the term beam refers to a slender member that carries transverse loading. Okay, if let me note, if your beam is like this, right? Your beam is like this. So, the loading is applied like this one. So, this is the transverse load. Load is applying perpendicular to the its longitudinal axis. So the term beam refers to a slender member that carries transfer loading that is applied force are perpendicular to the bar. Okay, let me unlock the meet. Okay. So in a beam, the internal forces consist of a shear force and a bending moment. In the beam, the force generated, internal force generated is due to loading. There will generate a shear force and a bending moment. Okay, this shear force and bending moment acting on the cross section of the bar. The shear force and the bending moment usually vary continuously along the length of the beam. So if this is your length of the beam, must be shear force is here, must be like this. At this position, shear force might be like this. Okay, so along the section, your shear force and bending moment different. At this point, your shear force can be different. At this point, your shear force can be different. The internal forces give rise to two kind of stresses on a transverse section of beam. Number one is normal stress that is caused by bending moment. Okay, and number two is shear stress due to shear force. So, due to these forces, shear force and bending moment, two types of stress generally generate. One is normal stress and one is shear stress, and we have discussed these two terms in our last classes. So knowing the distribution of the shear force and the bending moment in a beam is essential for the computation of stresses and deformation, okay. So what is the need of this shear force and bending moment? So when we design a structure, a beam, slab, column, there will be some in not in column, beam, slabs, struts, there will be some shear force and bending moment. Why we need to know this shear force and bending moment? Because we will design the structure based on those stresses, right? Due to shear force, it will generate normal stress. So to reduce the normal stress, we'll provide reinforcement. We'll design the structure for that normal stress. Again, we'll design the structure for this shear stress. So there are different types of beams are divided into different types of beams. So this one is simply supported beam. Okay, why simply supported beam? Because it has one roller support and one is pin support. Okay, this roller support cannot be provided here because you know this can resist only vertical motion, not horizontal motion. But your pin support, it resists your horizontal motion also and vertical motion also. So always remember, in practical world, so roller support is not provided at both the ends. Okay, so if one will be roller, other will be pinned or fixed or any others. So this is a simply supported beam. So in simply supported beam, one support is pinned and or you can call it as hinge, and one support is your roller support. And as we have studied in a method of joints and method of section, that roller support give reaction only in vertical direction, and your pin support gives two reaction, R1 and R2. So this is your simply supported beam. This is about support. Now let's talk about load. So see, this is the uniaxial, this is the point load, or you can say concentrated load. That means load is acting at this point only. There is no load at this point. There is no load at this point. Okay, so this load is also called as sorry, it is also called point load because because it is acting at a point. Okay, or it can say as concentrated load. Okay, so beams are classified according to their support. So generally beams are classified according to their supports. A simply supported beam as shown in figure, the pin supported prevents displacement of the end of the beams, but not its rotation. Yes, this pin support does not prevent its rotation. Okay, pin support only prevents your vertical and horizontal motion. The term roller support refers to a pin connection that is free to move parallel to the axis of beam. This type of support suppresses only the transfer displacement. So this supports only this transverse displacement, not this one. Okay, so that is they are talking about. Next, we have cantilever beam. Cantilever beam means it is one point will be fixed, is built into a rigid support at one end, with the other end being free, as shown in figure B. The built-in support prevents displacement as well as rotation at the end of beam. So this is the cantilever beam. One part is this part is fixed. Okay, this part is fixed. As you know, fixed connection. This is called fixed connection. Your cantilever beam is like this. They have drawn in. They have made fixed at this point, but it's okay. So in cantilever beam, what happens? One end will be fixed, another one end will be free. So this is a cantilever beam. So this fixed support, it will have three reactions. One vertical, it will resist vertical rotation movement, horizontal movement, and one rotation also. Okay, this rotation creates movement. So it will resist your movement, it will resist your vertical motion, it will resist your horizontal motion. So it will resist three reactions. Okay, next one is your overhanging beam. Overhanging beam means some part of the beam will be overhang. So just see the example. This one is the overhanging beam. One roller support, one pin support, and one part is overhang. Okay, this part is overhang, this part is overhang. Sometimes only this part will be overhang. Okay, and this is the point load. So is supported by a pin and a roller supported with one or both ends of the beam extending beyond the support. So they are extending beyond. So this is the overhanging part. This is the overhanging part. Either you may this is the condition, or you can get a situation like this also. Suppose this is the pin supported and this is the roller supported. This is the roller supported. So this part is also overhang. So this will also called as overhanging beam. Okay. The three types of beams are okay. So we have studied simply supported beam, cantilever beam, and overhanging beam. So all these three types of beams are statically determinate. Remember this word. Have you remembered this word? Statically determinate. Because the support reactions can be found from the equilibrium equations. So what are the equilibrium equations we have? Summation of all the forces equals to 0, or you can say summation of all the vertical forces equals to 0, summation of all the horizontal forces equals to 0, and summation of very difficult if I remove okay, so summation of fxx equals to 0, summation of fy, that means all the this is summation of all the horizontal forces equals to 0, summation of all the vertical forces are the 0, and summation of all the moments about a point should be 0. So these are the three equilibrium equations we have discussed earlier. So these three beams, simply supported, cantilever, and overhanging beams, are statically determinate. Why? Because the support reactions, these are the support reactions, right, can be found out from these equations. If we cannot find this support reaction, then your beam will be called as statically indeterminate, right? Just recall from the earlier classes. A concentrated load such as P, in contrast, a distributed load is applied over a finite area. So your concentrated load, see, this is concentrated load. It is applied only at a single point. Okay. If the distributed load acts on a very narrow area, the load may be approximated by the line load. So your let me unlock the meeting. Some students are in the way. So we have studied the different different types of beam. Now we'll study about why it is not okay. So we have studied about different types of beam, and now we'll study different loads. So this is point load, or this is the concentrated load. See, this is so types of load we have studied. Point load. Number one is your point load, right? It is acting on a particular point. Next we have UDL, uniformly distributed load. What it says, uniformly distributed load. So see, this load is uniformly distributed. This will have unit of kilonewton. This will have a value, means unit will be kilonewton, and this is says uniformly distributed length. So it will be distributed throughout the section, or maybe at some section. Suppose this, see in this figure, this load is uniformly distributed over the whole section. Okay, so this is UDL, and it has unit of kilonewton per meter. Suppose I have given 5 kilonewton per meter. Suppose this W naught is 5 kilonewton per meter. So this 5 kilonewton meter is along the whole. Suppose the length is 6 meters. So this 5 kilonewton is acting along the whole 6 kilonewton. Okay, 5 kilonewton is acting at every 1 meter distance. So this is called UDL, uniformly distributed load. Okay, and intensity, see, Newton per meter, kilonewton per meter, and LB. The weight of the beam is an example of distributed loading, but its magnitude is usually small compared to the load applied to the beam. So in this analysis, shear force and bending moment, we don't assume the weight of the beam. Okay, so we got point load, UDL, and there will be one more load, UVL, uniformly varying load. It will be like this. So have you understood? We have point load, we have UDL, uniformly distributed load, and I can also, let me give you one more example of uniformly distributed load. Suppose this is a beam of 9 meters. Okay, it is okay. You will get one more type of beam, fixed beam. Okay, we have studied simply supported, cantilever, overhanging. There will be one more beam, fixed beam. Both the end will be fixed. This will have 3 reactions, this will have 3 reactions, right? So both the end will be fixed. Suppose this is UDL. Okay, UDL is acting at a distance of suppose 3 meter, and there is one more load which is point load at distance 2 meter from this end. You can get a beam like this also. So this UDL is acting at a distance, it is acting at a distance of 3 meter only, and there is one more load, point load. Okay, and this UDL, this means that the, suppose this is 5 kilonewton per meter. So it says that 5 kilonewton per meter is acting from throughout the section, throughout this section, only this section. So at only this section, your load is 5 kilonewton per meter. But again, you are getting a point load. So I want to say that UDL can be applied. UDL will apply along the some distance throughout the distance will be uniformly distributed. Either it can take the whole section, or you may be given a just simple part. Okay, next we'll have UVL, uniformly, you can write this word, uniformly distributed load, UDL, uniformly varying load, UVL, and one we have point load. And we have 4 beams, simply supported, cantilever, overhanging, and fixed beam. Both the ends will be fixed, and we will get 6 reactions, as fixed support has 3 reactions. So when both the ends will be fixed, so we'll get 6 reactions. So let's see UVL, uniformly varying load. So this will be like this. At some point it will be high, and it will be like this, less load. It is varying. At different point of the beam, it will have different loads. So it is also called uniformly varying load. See, at this point the load is high. At this point the load is high. So you can get this type of load also. Uniformly, it is uniformly varying. Uniformly varying means getting different at different points. Let me add some students here in the waiting list. Okay. So got it? We got point load, UDL, UBL. So this is the prop cantilever. This is the prop cantilever. One part is cantilever, another one is supported at roller support. So one will called as prop cantilever. And see, UBL is applied over a certain section. This is the fixed beam. Both end is fixed, and it is having some point load. So anyone can you can get any situation. So you should know what type of beam is and what type of load is acting on that beam. Okay. I'm shifting my screen. Is it visible? Chapter, it is written chapter 2 shear force and bending moment. It is visible? Please respond. My screen is visible. I have shifted. Chapter 2 shear force and bending moment is written. Okay. So see, this is our structure. This is my structure. Okay. This is my structure, practical structure. These are the slabs, these are the roof beams, and these are the columns. So these, see, if I take this beam, if I want to take a beam on, if I want to take this beam, so this is fixed at both the ends. So generally in day-to-day life, we normally take fixed beam, okay. But in other structure like bridge and all, you may get a simply supported beam and overhanging beam. Okay, here you can take, see, this is the fixed part, right? This is the fixed part. So we need shear force and bending moment to find out the forces in these beams. When you will come to your seventh, eighth, yeah, I mean in the final year, you will get to know the importance of shear force and bending moment diagram. Okay, from this shear force and bending moments, we draw their diagrams. We get to know the variation of shear force along the beam and the variation of bending moment along the beam. Okay, so this is you can take an example of this beam. Suppose I have given this beam. So if I'm asking what will be the shape of shear force, find out the shear bending moment. So basically, what is the need? From shear force, we design shear reinforcement. Okay. Jonas sir will talk about this shear reinforcement and flexure reinforcement. From IS 456, there is a clause for shear reinforcement, there is a clause for flexure reinforcement. You have this in your semester design of beam, so you will get this values. So for designing those beams, you should know what is the shear force you are getting on that beam, what is the bending moment you are getting on that beam. Okay, so we'll start how to find. So first of all, you should know the types of beam we have discussed. Simply supported, fixed, cantilever, overhanging. Okay, what is the effect of loading on beams? Okay, the force that causes shearing is known as shear force. So what is shear force? The force that causes shearing. And the force that results in bending is known as bending moment. So the force which tries to bend the structure is known as bending moment. Okay. So these are the examples. Overhanging beam. This is the overhanging part. This is the simply supported beam. This is the cantilever beam, which one and fixed. So it will have vertical, horizontal, and one movement. Roller support will have only one reaction. Pin support will have two reactions. These are the different types of support. We have discussed determinate beam and indeterminate beam. So the beam which where we can find the support reaction by using these three equations, that will be determinate, and where these equation will be insufficient to find the support reaction, that will be indeterminate. So see, this will be a kind of your shape of shear force and bending moment. See, assume this one as a complete bending moment, but is the from this in this position you are getting low load, in this position you are getting high load. and there is one point load also. In this, there are variation in loads, right? So based on those loads, you will get a shape of shear force, and again you will get a shape of bending moment. You know the formula of moment, force into distance. So I'll start with this one. Okay, I'll start with let's jump into numerical so that you understand. So the beam shown below is simply supported by a pin at A. This is the pin or hinge support, and roller support at B. Calculate the reaction at both the supports due to loading. So two loads are given, 20 kilonewton and 40 kilonewton. So somewhat we have discussed how to find the support reactions in this beam. So what will be your first step? Your first step will be first to draw the free body diagram of this beam, and then find the support reactions. What will be the support reactions here? So I'm giving you 2 minutes, not 2 minutes. Let's okay. Just take 3 minutes to find out the support reaction in this beam. Just recall your section of method of section and method of joints class. Quickly write this question in your copy and pen, and I'm asking to find out the reaction, support reaction in this beam. Okay, this is your this marks will go to your class interaction. So tell me what will be the support reaction on this beam. Find out. How many students? There are 43 students. I need answers quickly. I'm asking you to find the support reactions on this beam. Find out, and tell me the answer. What will be the support reaction? This is same like method of beams and method of joints. We have found out your support reactions. What we do first? We first find out. First, we draw the free body diagram of the member or structure, or the question or the value means we have been given. We first draw the free body diagram, right? Then we find out support reaction. So in this case also, your first step will be to draw the free body diagram of this beam, and then find out the support reactions using those equilibrium equations. So this is very basic. Let me know the answers. Quick. Section A students are very more active than me. So reply me. Yes. If someone didn't understand, then another issue. Let me know if you didn't understand also. I'll explain once again. But tell me the support reaction. This is same like method of joints and method of section you did. First, draw the free body diagram. Then find out your support reaction. Ma'am, is that roller? Yes. One is pin support, one is roller support. One is roller support, another at B you have roller support, at A you have pin support, or you can call hinge support. You have done the assignment also, so you should know how to find the support reaction. Very basic. Quick. Anyone found out? From 43 students, no one is able to find out. What happened? 43 students. Are you there or just logged in the class? AY 33 point. Very good. Raju? Very good, Raju. What about others? What about others? I cannot wait long. So this is your marks to your class impression, right? Okay. Good, Rohini. Good. Supposed to be good. Anyone else? Okay. So see the figure. Raju, Rohini, good. Supposed to be good. Blue, good. Okay. Okay. Move on. So this is the free body diagram. Roller supporter is removed by your one reaction. Pin this 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 pin support is removed by these two reactions. So first, see, there is no any other horizontal force, right? There is no any other horizontal force. So my reaction got 0. RAX is your 0. Next, let's move. Let's take by taking the moment at B. So I'm taking the moment at B. So what will be my first, you know, how to find the moment? Force into distance, right? So moment about B, what will be this one? RAY into 9, and it will go clockwise direction. So positive RAY into 9 minus minus why minus? Because this 20 Newton is downward and it will come to anti-clockwise, and the distance is 3 plus 4 7, so that's why minus 20 into 7. Next, again this will come as anti-clockwise, that's why 40 into 4, 40 into 4 equals to 0. Solve this equation, you will get RAY equal to 33.3 kilonewtons. So we have found out this one. Next, what we left, we have used moment equation, we have used Fx equation. Now let's come to summation of all the vertical forces equals to 0. So what are the vertical forces? RAY plus RB minus, because these are in downward direction, that's why minus 20 minus 40 equals to 0. We know the value of RAY, you have got RBY as 26.7 kilonewton. Understood? Understood or not? Okay. So draw the free, if okay, let me discuss this one. So this is the beam, roller supported, pin supported. There is one UDL also, and you have been given a support reaction token. So how to find the support reaction? So this is the free body diagram. Roller supported was removed by one reaction. Pin supported is removed by two reactions, RAX, RAY, and this is the 20 kilonewton, and this is the UDL. So see, for the UDL case, how will you find the force? Just for UDL case, okay? I'm not discussing the, as you know, for the point load, you have a unit of kilonewton. The force has a unit of kilonewton and newton, so this is okay. But see, this is 15 kilonewton per meter. So how will you, and force has unit of kilonewton. So how will you make it kilonewton? So there is one way, 15 into, we are not once again. So for the UDL case, if you need to find the force, how will you find force? 15 into this 15 kilonewton is applied at 3 meter distance, right? So multiply by 3. How? 15 kilonewton per meter, right? And you are multiplying with again meter. So this meter will cancel. You will get the force in kilonewton. So that is how you need to. So 15 into 3 will be 45. So that is how you need to find the length force in UDL. What will you do? Whatever with the load given to you, you have to multiply with the distance. Suppose this distance was, suppose 15 kilonewton is acting at 5 meter distance. So you have to do 15 into 5. Okay, that's how you will get the UDL in kilonewton. Understood this part? Understood this part? Okay. Hope you have understood. If you have not understood, just stop me right there, okay? Because it is difficult to go back to from the first point. So where you don't understand, just stop me at that point, okay? Please cooperate with me because we have limited time, right? So there, at the point you didn't understand, type in the chat box. I have opened my chat box. I'll correct. I'll try to understand. Repeat there itself. Again, if I need to start from the beginning, yeah.
Ma'am,
Yes.
just point 5.5.
That
I'll
I'll,
explain.
yes, yes, that I'll explain. First, you have understood this part. How to take the load. How to take the load for 15 kilonewton UDL. You have understood.
Yes, ma'am. Yes, ma'am.
Okay, okay. That I'll come to 5.5. So hope this part is clear to you all. Now let's take. See, there is no horizontal force in the beam, so Rx will be zero. So this part is over. Now come to the movement part. By taking the movement at A, that is, I am taking the movement at A. Okay. So the first reaction will be this one. I can start with anyone, but I'm starting with RBY. So this RBY is coming. If we take a movement, it will go anti-clockwise. That's why minus RBY into what is the distance? 4 plus 3, 7 meter. Done. Plus y plus c. This 20 and this is the force. This is the movement. So it will give us clockwise movement. That's why positive. 20 into 4 plus 3 plus 2, 9. Done. Done this part. Now let's come to the main part for the UDL. So we have taken this force into distance, this force into distance. Now we have to take 15 kilonewton. So I have told you how to find the force for this. As you know, moment is equal to force into distance. And I've already discussed how to take how to take the force of UDL. You have to take the load into the distance it is applying, the distance where it is getting where this load is acting, 3. So this will be its force, 15 into 3. So this is its force. Done. Now come to distance. So one distance will be one distance will be 4, this force. Now you cannot take 3. See, this 15 kilonewton is acting at 4 also. It is acting at the end of 3 also. Right? It is uniformly distributed, right? So you cannot take the just 4 distance. You cannot take just 4 distance, and you cannot take the 7 also, because it is acting in the uniformly, na. So what you will do? You will take half of this distance. That is 1.5 always. So that's how it will become 15 into 3 into 4 plus 1.5 will be 5.5. Have you understood? Have you understood? Please respond.
Yes, ma'am.
Okay, what about others? Let me take another example. Let me take a quick another example. If the distance is different, suppose you have been given a distance of 9 meters, suppose. Okay. Suppose this distance, suppose this distance was your 9 meters. Okay. You have founded the force into movement for this force into this distance. Done. Then this is in downward direction. Again it will take anti-clockwise movement. Okay. So that's why minus. Next, force. I have suppose this is the 9 meter. So I have discussed that how to take the force for UDL. For UDL, what is UDL? Uniformly distributing load. So it is uniformly distributed load over the length of suppose 9 meters. So how you have to take the force? Suppose forget about the 15 kilonewton. Suppose this is 20. 20 kilonewton per meter is acting at a distance of 9 meters. So how you have to find the force? Always find the force for the UDL. For the UDL, 20 into 9. Done. Now the distance. Distance from A. 4 plus what will be the half of 9? Why half? Because it is acting at 4 also. It is acting at the end of 4. At the end of 9 plus 4, how much it will be? At the end of 13. It is acting at the end of 13. It is also acting at the end of 4. So you cannot take 13. That will be incorrect, and you cannot take 4. That will be incorrect. So what you have to do, what will be the easy point? Take the half of the distance. So 9 का half कितना होगा? 4.5, right? So that's how it will be. 20 into 9, and the distance will be 8.5. Have you understood? I won't know why it is negative signs for UDL. It is in clockwise direction, right? No, it is not in clockwise direction. It is in How it will be clockwise direction. It will give movement. This is the force, right? This is the force. This force, and this is the movement. It will come this way. This is the force. This force. This is the movement. But see this. If I take this force, it will give movement this direction, right? And this force will give if the distance. Okay, distance is this direction. Okay, there may be mistakes. Some mistakes in there. Yes, this is in clockwise direction. We have to take the negative. Yes, yes, you are right. This would have positive value because this is if this distance if this distance if we take movement about this point, then it could have negative value. But we are taking this side, so it will go here. The distance is in this direction. It will go clockwise. It will go clockwise, right? So this will be positive. There may
Ma'am, we are taking it moment at A, right?
yeah. We are taking movement at A. Yes, at this point. So
And ma'am, it will be clockwise, right?
yeah, it will be clockwise. So they may have mistake. So take it as positive. Okay. So you found our equations. You have found out the equations and find out the RBY. So movement part is over. Sum of horizontal forces is over. Now come to sum of the vertical forces. What are the vertical forces? RAY and RBY positive upward direction and minus 20 is in downward direction. And this is the load. Why 45 you have understood, I guess. 15 into 3 force kilonewton. So you have found out the RAY. Simple, right? Write this question and do it as homework. Try to find this one. If you don't understand, I'll discuss in the next class. Okay. Write this one as homework. Find out the support reaction. Just write this question and find out the support reaction. Done? Just take the screenshot of the question. Okay. So in the next class, we'll discuss the shear force and bending moment diagram. Okay. We'll discuss the shear force and bending moment diagram for these equations. So hope this support reactions was clear to you all. We'll discuss UVL in the in on Thursday. This for this load, how to find a support reaction for the fixed beam and UVL, and how to draw the bending moment and shear force diagram for this kind of load in the in on Thursday. Today we'll try to learn how to find shear force and bending moment, how to draw shear force and bending moment diagram for these kinds of beams. Okay, so okay, write your roll numbers in the chat box. Please write your roll numbers in the chat box. Everyone wrote their roll number? Should I end the meeting? Hope everyone wrote their roll numbers. Okay. Okay. KGK. Write your roll number fast, fast.